Hi, in this video we are going to see about a Python project which is entitled as Heart Disease Prediction with Machine Learning, which is an enhancement of IEEE base paper titled Effective Feature Engineering Technique for Heart Disease Prediction with Machine Learning, which is an IEEE 2023 journal paper. Before seeing the execution of the project, let me brief about this project. So we all know that nowadays heart disease is increasing day by day all over the world due to change in the lifestyle activities, change in sleeping patterns, change in food habits, etc. So even some people who's working in gym, they are getting the heart attacks, and we are seeing such kinds of several deaths in day-to-day life. The problem with the heart disease is like it does not shows much symptoms before, so it makes the attack immediately. So the preventive measure is the only thing. So here the early detection of this heart disease prediction is one of the important factor. So we should apply some scientific methodology for identifying the heart disease early. So in this base paper, the authors have used a technique called Principal Component Heart Failure, PCHF feature engineering technique for this heart disease prediction. But we are not going to use the same as mentioned in the base paper. So now let us see about what is our proposed system. So we are not going to use any feature reduction technique. So instead we'll be using 4 different distinct models for it. So the first using the random forest classifier, second bagging classifier, third is using SGBoost, and fourth is using LightGBM. So even in our project list and in YouTube channel, we have already done various heart disease prediction using machine learning, but we have used only single model. But here you can see some 4 different models, and also like LightGBM, SGBoost, these kinds of models are a new proposed one for this enhancement from the base paper. So now let us see the abstract document. So here you can see the IEEE base paper title, which contains the effective feature engineering technique for heart disease prediction with machine learning, or you can use our proposed title, that is heart disease prediction with machine learning. So this is the IEEE base paper abstract. So coming to our proposed abstract, so here you can see the proposed abstract which is developed using Python. And coming to the model, so we have used 4 prominent machine learning algorithms: random forest classifier, bagging classifier, SGBoost, and LightGBM. And another thing is like we have achieved the accuracy train score of 100% and test score of 100% for the random forest classifier. Same accuracy train score of 100% and test score of 100% for bagging classifier. Same accuracy train score of 100% and test score of 100% with the SGBoost. And same for the LightGBM, we have achieved accuracy train score of 100% and test score of 100%. So all these details have been mentioned here. And coming to the data set part, so in the data set part we have around 1025 data set records, which contains around 14 distinct features in it. So I'll show you the data set part. So in the source code folder model, we have this hard data set for. So here you can see this is the data set that we have trained up the system. So as mentioned, we have around 1025 data set records with the 14 distinct features in it. So here you can see the features like age, sex, CP, TRES BPS, CHOL FBS, REST ECG, THALACH, exang, old peak slope, CA, tal, target kinds of things. So here CP means chest pain, TRES BPS is resting blood pressure, CHOL is serum cholesterol, which is measured in mg/dl, and FBS is fasting blood sugar, REST ECG is resting electrocardiographic, THALACH means maximum heart rate achieved, and exang, that is EXANG means exercise induced angina. Old peak means ST depression induced by the exercise, and slope is the slope of peak exercise, and CA is number of major vessels, and THAL has three features, that is 0 means normal, 1 means fixed defect, 2 means reversible defect. So here we have a target that is 0 or 1, which means that the prediction result heart disease or not. So these are the about the data set part. So coming back to the abstract document, so here you can see about the existing system. So as mentioned, so we are considering the base paper as an existing system where they have used PCHF, that is principal component heart failure feature engineering technique. So that is being mentioned in the existing part. These are the existing system details. And next comes the disadvantages of the existing system. So we have listed about the disadvantages of the existing system, and so we are proposing the proposed system. So the proposed system contains about the 4 distinct machine learning models, and the goal is to achieve the high accuracy, which is 100% accuracy on both test and train. And we have mentioned about the data set part and the models, about the models and the accuracy that we have achieved. So coming to the advantages of the proposed system, so we have listed about the what are the advantages of our proposed system here. And coming to the system architecture, so we be using the input data set and the pre-processing feature selection is made, and the 4 classifiers have been applied here, and the prediction result is whether it is heart disease or not heart disease, and we'll show the performance analysis and graph pattern. So coming to the system architecture, you can find the hardware requirements and software requirements as mentioned. So we'll be using Python, and the version is Python 3.10.9, and the web framework is Flask. Front-end part is done using HTML, CSS and JavaScript, and this is the reference, that is the base paper reference for it. Before execution, make sure that you have fulfilled the requirement that is mentioned in the requirement file with the exact version of the Python and the library is installed in your system. Now let us see the execution of the project. So just copy the source code location, go to your command prompt. Now go to the drive location where you have pasted your code. So in my case, I have pasted in F drive. So just go to the F drive by entering F. So I am in the F drive now. So now type cd space and paste the location that we have copied and click enter. So now we are into the source code location. Now type python app.py and click enter, and kindly wait for few seconds. So now you can see the URL. Just copy this URL, go to any of your browser. I'm going to Google Chrome. Just paste the URL that we have copied and click enter. So now you can see the home screen or welcome screen of the project with the project title Heart Disease Prediction with Machine Learning. So now just click this login menu. Once if you click this login menu, it will be navigated to the login page. So kindly note that this is a static login page because we have not used any database in the project. So just enter the default username and password as admin and then click the login button. So now you can see the login success message and click OK. So now it will be navigated to the upload part where you need to upload the data set. So just select this choose file option. Now go to the source code location where you can find the upload.csv file and then select this upload button. So once uploaded, it will be navigated to the preview part. So where you can preview the data set that we have uploaded. So as mentioned earlier, it shows the features like ID, 6 kinds of things, and if you scroll down till the end of the page, so you can find the complete data set has been loaded into the preview part with the 1025 data set records. So in the end of the page, you can find this click to train or test button. Just click this and kindly wait for a few seconds. So now you can see the training finished message and click OK. So now it will be navigated to the important part, that is the prediction part. So where now we have made some enhancement in the user interface slide so that the user can easily enter the answer details whichever has been asked, and they can find the prediction result. So we have made this kind of enhancement also from the existing system. So let me show you that one by one. So first question is like, can I know your age? So let me enter the case here with the age of 52 here, and then click next. So here the next question is, can I know your sex? So here we have pasted male and female, whichever is you can select. So in the case I'll just select the first case with the male here and click next. And next one is, what type of chest pain you have? So here we have options of typical angina, atypical angina, non-anginal pain, asymptomatic. So for this my case I'll just enter typical aginoma and click next. And next one is, what is your resting systolic blood pressure? So in my case I'll just enter the detail as 125. So these are the data set, whatever I'm entering, these are the things that is available in the data set. So in the data set they are just made in a short form, that is CP plus P CHOL like that. But here we are improving the user interface by expanding the details so that the user can easily understand without the non-technical terms. And now after entering this one I'll click next. So next one is, enter your serum cholesterol in mg by dl. In my case I'll just enter my value is 212. So this is the value I need to enter, and then click next. So is your fasting blood sugar is greater than 120 mg by dl? So in my case I'll just give no and click next. So next one is, which of this your resting cardiograph, that is ECG? So in my case there are three options, that is normal, having ST, or left ventricular hypertrophy. So in my case I'm giving having ST and then click next. So tell me the maximum heart rate achieved by you. So in my case I'll just give the value as 168 and then click next. So do you exercise included angina? So let me click the answer as no for this case and then click next. So what is your ST depression value induced by exercise related to rest? So my value I will enter it as 1 year and then click next. Now the final is, what is the slope of your peak exercise ST? That is 4 options: up sloping, flat and down sloping. In my case, first case I'll just give down sloping and then click next. So final is like, here there are 4 models. As mentioned, we have developed the 4 models, so you can enter which model you wanted. Accordingly the result will be predicted. So I'll just enter random forest and then click submit. So now you can see the prediction result that congratulations, you don't have heart disease. So this is the model that you have used is random forest, so that is also updated here. So now quickly I'll just enter the other case without explaining one by one. So now let me click the prediction menu again. First age is 58, sex is female, typical angina, resting systolic blood pressure is 100, serum cholesterol as 248, is no, normal, no, 1, flat, and this time let me select SG boost, because any of all the model achieve 100% accuracy, so the maximum there will not be any difference in the prediction. So now let us see the prediction result for this case and click submit. So now you can see the prediction result is, oops, you have heart disease, which is predicted from the model as GBoost. So now quickly let me click the prediction menu again. For this case I'll give the age as 43, sex as female, this one is typical angina, (132), (341), yes, is normal, 136, yes, three, and this is flat. And now this time I'll go for the bagging classifier and click submit. So now you can see for this case the patient does not have the heart disease and the model that we are using is bagging classifier. Finally I just go for the prediction menu again to enter a final case with the age of 50, next, female, typical angina, 110, this is 254, no, this is normal, this is 159, this is no, and this is a 0, and the exercise ST segment is down sloping. And finally I'll select this LightGBM model for this case and click submit. So now you can see the case has the heart disease, so it shows oops we have heart disease, and the model that we have selected is LightGBM. So for testing I have given you 4 cases, first by selecting the 4 different models, and 2 cases considered as 2 cases predicted the result as having heart disease, and 2 cases show the result as does not have heart disease. So in this way you can check with all the test cases or the trained data with the models, 4 different models. So to shorten the video I'll move to the next part of the video, that is the performance analysis part. So just click this performance analysis. So in the performance analysis we have the performance analysis parameter for all the 4 modules: random forest classifier, bagging classifier, GBoost, and LightGBM. I'll show you one by one. So first, the random forest classifier, we have the recall, precision, and F1 score for both the cases 0 and 1, and also the confusion matrix for the true and predicted label. And also the bagging classifier, we have the recall, precision, and F1 score for both the cases 0 and 1, and we have the confusion matrix for it. And for the GBoost classifier, we have the recall, precision, and F1 score for both the classes 0 and 1, and we have the confusion matrix, the true and predicted label of it. And coming to the LightGBM, we have the recall, precision, and F1 score with both the cases of 0 and 1, and we have the confusion matrix for it. So as all the model achieve 100% accuracy, you can see the scores values are same. And final comes the chart part. So just click this chart menu, and kindly note that this is a static chart because we have not used any database in the project as been intimated earlier. So this chart is being depicted from the data set that we have used. So in the data set part, we have the 70% with the heart disease value and 30% with no heart disease value. So that is being labeled here as manually. This is being plotted. So that is the reason I said this is a static chart. And finally comes the accuracy score chart. So as we have achieved 100% for all the models, the graphs remain the same for all the classifiers, all the models, that is random forest classifier, bagging classifier, GBoost, and the LightGBM. So this is the accuracy graph. So in the chart part we have 2 charts, that is one with the data set depicted chart and also the accuracy chart. And now let me log out. And this is all about the project heart disease prediction with machine learning using Python. And thank you for watching.